Hi everyone. Today our topic is inverse trigonometric functions, and this is our first lecture. So in class, when I start this topic, the student asked me one thing said how the inverse of trigonometric function exists, because when I taught them in the class, I said uh, if a function is if f is a function and which is that it is 1 plus onto. So if the function is both 1 and onto, then this function is called bijective function. This function is called bijective function. And if the function is bijective, then its inverse exists. If inverse exists. And we know that all the trigonometric functions, all I call T functions, all trigonometric functions, and you know that all trigonometric functions are many one. If they are many one, so they are not bijective. So since all the trigonometric functions are many one functions because they give same value at the different values of x, so therefore they are not bijective. So how the inverse exists? That means their inverse does not exist. Inverse does not exist. Okay, but we have to read the inverse trigonometric functions and how we can define the inverse trigonometric functions if their inverse does not exist. So first of all, what we do, we curtail the domain. We make the domain, we cut the domain, or we shorten the domain in such a way so that the functions become 1 and onto. For example, in case of a sin x is a trigonometric function and its domain is the set of all real number, whole real number line. So in the real number line, it is what? It is not bijective. It is many one. So what we do, we will select some portion of the domain, whether it is 1 and onto. It becomes the bijective. So our first function is we are going to learn, that is sine inverse x. Sine inverse x, y is equal to sine inverse x. Sometime it is also written as y is equal to arc sine x. Okay, na? Arc sine x. In that way it is written. So we have to select the domain of sin x function in such a way so that the sin x is become bijective. So now what is our domain in that situation? So first of all, I am going to draw the graph of sin x function in a selected domain so that it will take all the values from -1 to +1. So now if I draw like that, in the first quadrant, suppose up to pi by 2, and in the fourth quadrant up to minus pi by 2. So if I take sin x function in the domain minus pi by 2 to pi by 2, at pi by 2 height is what? At minus pi by 2 height is -1. Clear? So you see that sin x here takes all the values from -1 to +1. So that means it's become onto functions. And every horizontal line in that case cuts the curve exactly at 1 point. So therefore, in this domain, it is what? 1 and onto. So therefore, it inverse must exist. Okay. So here I am taking the graph of y is equal to sin x. And the domain here is minus pi by 2 to pi by 2. And range of this sin x is here -1 and 1. So when I will draw its inverse, sin inverse x, so this domain become the range and range become the domain for the sin inverse function. So how to draw the sin inverse functions? So we have to take the reflection of this sine curve with respect to the line y is equal to x, y is equal to x. Okay. So this is the line y is equal to x. If I draw the curve here, sine inverse x, it becomes very becomes very unclear. Okay, na? So I'm drawing the curve here. So this is my line y is equal to x. You notice that here on the curve one point present pi by 2 comma 1. So after reflection it would be 1 comma pi by 2. So range become domain, domain become range. So this will be 1 and this will be minus 1. Add the 1, height will be pi by 2 and minus 1 it will be minus pi by 2. So this portion of the curve below the y is equal to x, but after reflection it will be just above the y is equal to x line. So it will be look like this. So curvature will change. Curvature will change. So this will be the y is equal to sine inverse x. Height of the curve is pi by 2, and in the below you notice that it is minus pi by 2. Okay. Here, when you move from 0 to pi by 2, or from minus pi by 2, the curve is increasing. Here also, after reflection, curve is increasing. Only the coordinates will change. Uh, okay, now. So therefore, on the curve, it is the point 1 comma pi by 2, and it is minus 1 comma pi by 2, and this is the line y is equal to x. Few characteristics you have to remember about this curve. So number one, you can say that first of all, domain of the sine inverse x. So domain will be minus 1 to plus 1. What is the range of this function? R for range here. Range is minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So question is the this value is bounded? Of course, because its maximum value pi by 2 and minimum value minus pi by 2. So it is the bounded function. The function is increasing because here you notice that the sine function is increasing. It inverse also increasing function. It is increasing. It is periodic. Answer is no. It is aperiodic. Aperiodic. That means it is not periodic. No inverse function is periodic. Okay. Now, next is what? It is not periodic. It is bounded, increasing, done. Domain we have completed. Range we have completed. Any other points? If you move the curve, whatever the value you have take here, same value you will get in the third quadrant. That means what we can say that it is the odd function. Okay, na? With respect to the origin, it is symmetry. It is the odd function. So this 6 point you have to remember about sine inverse x. Okay, now coming to the next function, it is our first function. We call it is point 1. Next is cos inverse x. Y is equal to cos inverse of x, or you can write in short y is equal to r cos x. Okay, now. So first of all we will select or we will draw the curve of cos inverse function, cos x function, and we select the domain from 0 to pi. If we take this domain, then what will happen, all the values from minus 1 to plus 1 cos will take. Okay, so at the point pi it is minus 1, and at the point 0 it is 1. It cuts the x-axis at pi by 2. So this is the function of cos x curve, and here I am taking the domain from 0 to pi, and you notice that range of the cos is 1 to minus 1 to plus 1 covers in this range. Now our target is with respect to the line y is equal to x, we are going to draw the cos inverse x. We will take the reflection. What will happen? The points here is pi comma minus 1. So this will become minus 1 comma pi. At the minus 1, height will be pi. This is pi by 2 comma 0. After reflection, it will be 0 comma pi by 2. 0 comma pi by 2. This point is pi by, this point is 0 comma 1. After reflection, it will be 1 comma 0. 1 comma 0. Okay. So now you notice that the curve will be look like this. The curve will be look like this. The curvature will change. The fourth quadrant part will be in the second quadrant. Not perfectly drawn. I'm trying to draw this one. Stars will look like this. Yes, perfectly match. Okay, now. So look at the curve. This is what the height is. 1 minute. Increase the height here of the axis. These height will be pi. Okay. So what we notice that the cos inverse x is the decreasing function and its cos x and its inverse is also decreasing function. So first of all, we will find the domain of this function. So number one, what is the domain of cos inverse x? -1 to +1. What is the range of this function? You see that it is 0 to pi, covers 0 to pi. It is 0 and the maximum height is pi. So 0 to pi is the range of this function. Third point, it is bounded. Yes, it is bounded. All the values lies between 0 to pi. Maximum value pi, minimum value 0. Fourth is what? Fourth point is this function is decreasing function. When x increasing, height is decreasing. It is decreasing functions. All the inverse function is aperiodic. So it is also a periodic function, not periodic. And it is with respect to the y-axis, it is not symmetric. With respect to the origin, it is not symmetric. So it is neither increasing, it is neither odd function nor even function. So neither even nor odd, you can write as any n, no, neither even nor odd. Clear? Now our next function is the tan function. So we have y is equal to tan inverse x. We draw, it is also written as arc tan x. So if I ask you in which interval I will draw the tan so that it will takes all the possible values. It will cover its range. So your answer should be, or your answer will be minus pi by 2 to pi by 2. So it is the asymptotes x is equal to minus pi by 2. It is the asymptotes x is equal to pi by 2. For tangent, it is 0. It is our x-axis. It is not 0, it is origin. And this is y-axis. And all of you know that tan inverse look like this. Now this one, and this going to minus infinity. Though it is meaningless to write the coordinates of this point, but I will write here to for the interest of drawing this tan inverse x functions. So at the point pi by 2, the curve approaching infinity, it is meaningless to write the coordinates as minus pi by 2. It is going to minus infinity. So it will give the sense that when you take x is minus infinity, it will be minus pi by 2. When you take x is plus infinity, it will be going to plus pi by 2 and 0 is 0. Now this x is equal to pi by 2 asymptotes will become y is equal to pi by 2 asymptotes. So first of all, we draw the asymptotes. This is our axis. Okay. Now, first of all, we draw the asymptotes. This is the axis. Now, this is y is equal to pi by 2 asymptotes. And this is y is equal to minus pi by 2 asymptotes. When x tends to positive infinity, your curve will be going to pi by 2 but less than pi by 2. So it will be look like this. And here it will be going like this one. So it is, you can say that it's nothing but look like a, it is nothing but look like a snake. Okay. It will not touch the y is equal to pi by 2 line, but it's going to infinity. Okay, now the distance will be approaching to 0. So this curve I called a snake. Look like a snake. Okay, now you just see the snake and write all the points. Number one, domain of the tan inverse x. You notice that it is real number minus infinity to plus infinity on the x-axis. Range will be what? Second point. Range of this tan inverse x. Range will be in the open bracket minus pi by 2 to plus pi by 2. Its maximum and minimum value we don't know, but it is bounded function. It is bounded in minus pi by 2 to plus pi by 2. And fourth number point, it is increasing because here tan is increasing. When x increases, curve will be increasing. So it is also increasing. Fifth point, it is a periodic functions. And whatever you notice that after origin, whatever the height you are getting, when you just go beyond the left side of the origin, same height you will get in the downward. Therefore, it is symmetric with respect to the origin. You can say that it is a odd function. It is odd function. So next is what? Cot inverse functions. Next is our cot inverse x. Then we go to the next page. I hope this part is clear to everyone. Okay. So six functions. Out of six, we have completed three, and next three is left. Okay. Y is equal to, oh, this is our third functions. This is the fourth function that y is equal to cot inverse x. If I ask you, I want to draw the y is equal to cot x function. So in what domain I will draw the cot x so that it will be the bijective function. So your simple answer will be, sir, 0 to pi. If you take 0 to pi, then what will happen? It is 0. And you notice that the cot is starting from here and goes down, cut at the pi by 2 and going to infinity, like this one. Okay. Okay. Now this is x. This one is y. This is pi by 2. Meaningless of this coordinate 0 to pi, 0 to infinity. And when you going to pi, the curve approaching to minus infinity. So this x is equal to 0 and this x is equal to pi. And these two asymptotes, vertical asymptotes, will become the horizontal asymptotes. So now we are going to draw the cot inverse x function. Then after that we will write everything. Here you notice that the domain is 0 to pi and range is minus infinity to plus infinity. You know, let me check one thing, that what will happen to this tan inverse x, what I written here. Oh, tan inverse x range is minus, okay, correct. It is correct. So now this is y is equal to 0 and another asymptotes will be y is equal to pi. So your cot will become, look like this. It will not touch the y is equal to 0. Y is equal to 0 is nothing but the x-axis. So what we notice that this point will become pi by 2 comma 0, 0 to pi by 2. Looking at the curve, try to write these points. Domain of the cot inverse x. So domain is set of all real number. What about the range? Open bracket 0 to pi. Is it bounded? Your answer is yes, it is bounded. Maximum, minimum, we don't know, but it is bounded between 0 to pi. Next, it is bounded. Next point is what? Let me check here. Bounded. After that, we write increasing, decreasing. So curve is simply decreasing because cot inverse is decreasing. It inverse is also decreasing. Fifth point is it is a periodic functions. It is not periodic. Next is it is even or odd. So you notice that with respect to y-axis, it is not symmetric. With respect to the origin, it is not symmetric. So it is nano, neither odd, neither odd nor even any. neither even nor odd. Okay. Coming to the fifth functions, y is equal to cot. After that, we have sec inverse x. Sec inverse x is very the curve I want to draw here using some technique. We should notice that all of we know that cos inverse x functions. So from the cos inverse, I will want to draw the sec inverse functions. This is our cos inverse. This is the height phi at the point x is equal to -1. Here 1 is equal to 0. And this is the point. Through this point, I want to draw one horizontal line. Look like this. And this horizontal line is nothing but y is equal to pi by 2. This horizontal line is nothing but pi by 2. Y is equal to pi by 2. Okay. So when you want to draw the sec inverse curve from the cos inverse x, what we have to do, just take the reflection. The reflection of the lower part will be this right area by using the yellow color, this one. Again, it touches the axis. Sorry. Is x-axis. So take the reflection of this part, lower part is here, this one. And take the reflection of this upper part, like this one. So this yellow color portion is actually the sec inverse x. This yellow color portion is actually the sec inverse x. Is it clear? Anyone have any doubt? Okay. So here what we notice that number one point, you can say that domain of the function. Domain of the function is what? After 1 and before -1 it is defined. So you can say that mod of x should be greater than equal to 1. This is the domain. What is the range of this function? Range of the function is similar to 0 to pi, but pi by 2 will not come. So 0 to pi, this close bracket, but except this point, pi by 2. Pi by 2 will not occur. Pi by 2 will not occur because it is the asymptotes. Except this point. Okay, everything is fine. With respect to y-axis, it is not symmetric. With respect to origin, it is not symmetric. It is aperiodic functions. It is Nino. This point is enough for this curve. Now coming to the last one, that is sixth function, y is equal to cosec inverse x. Y is equal to cosec inverse x. So cosec inverse x we want to draw with the help of sine inverse x. So this is our axis. Sine inverse x, we know that this is our sine inverse x. It is at the point 1. It is at the point -1. So this is the curve of y is equal to sine inverse x. Okay. And this height is pi by 2. This height is minus pi by 2. So what we have to do, just we take the reflection of this portion, like this part, and the below portion, we have to take the reflection like this one. So this yellow portion is the your cosec inverse x function. Is it clear? Is it clear? Any doubt regarding this? No doubt. So what is the domain? Domain of this function, you notice that mod of x greater than equal to 1. After 1, before 1, it is defined. Number 2, what is the range of this function? So you can say uh, range is minus pi by 2 to plus pi by 2 except 0. So x cannot be 0. Okay. So this is our range. Or you can say that not x, it is actually minus 0. Okay. So this is the y value actually. And it is not a periodic function and neither even nor odd. Yeah. Okay. Okay. Wait. Whatever we take here, same value we will get in the O. So it is the odd function. Sorry, it is the odd function. The value is same in the first quadrant as well as in the third quadrant, but opposite in sign. Odd functions. So after getting the this idea, whatever or what you have to do, just make this table and revise with me. Your functions 1, 2, 3, 4, 5, and 6. Your function is sine inverse x, function is cos inverse x, function is tan inverse x. Then you have cot inverse x, then you have sec inverse x, and then we have cosec inverse x. Now find the domain of all these functions. What is their domain? So just recall with me here mod of x less than equal to 1, mod of x less than equal to 1. Here any real number, it is greater than equal to 1. Here is also greater than equal to 1. Next is find the range of these six functions. So number 1, close bracket minus pi by 2 to pi by 2. Cos is 0 to pi. All the value lies above the x-axis. For tan inverse x, it is open bracket minus pi by 2 to plus pi by 2. For the cot inverse x, open bracket 0 to pi. And sec inverse x is same as sec inverse what we get here. Range sec inverse 0 to pi except pi by 2. So sec inverse we have 0 to pi except pi by 2. And here we have minus pi by 2, 2 pi by 2, and except 0. So these things you have to remember in a table, in their graph also, because when you solve the questions, this idea you have to apply. This idea you have to apply. Okay, now we are going to solve few questions. Okay, one by one we are going to solve few questions based on this concept and the graph. Question number 1. So first we have very simple questions. Question number 1 part A. Sine inverse log of x base 2 is given, so we have to find the domain of this function. Domain we have to find. What is the domain? Here we also have to find the domain of this function. Okay. So now notice the solution one by one. Solution of A. It is the necessary condition that if sine inverse is given, it inputs must be less than equal to 1, greater equal to minus 1. And when the base is more than 1, then the log function is what? You know that log function is increasing function. Log function is increasing function. When the base is more than, suppose here log of x base a, where a is greater than 1. So since it is an increasing function, what we do, we have to remove the log x. So it will be 2 power 1 lesser than equal to x less than equal to 2 power 1. So what we notice that domain of the functions will be 2 to the power minus 1 means 1 by 2 comma 2. This is the domain. Come to the second question. Find the domain of these functions cos inverse within bracket x minus 3 by 2. What is the domain of this function? So it is also very easy question. Cos inverse x is defined only when the input is cos inverse x is defined when x is less than less mod of x less than equal to 1 or minus 1 less than equal to x less than equal to 1. So this is the criteria. Multiplying all the side by 2, it will be minus 2 less than equal to x minus 3 less than equal to 2. Now it will be minus 2 plus 3, that is 1 less than equal to x less than equal to 2 plus 3, 5. So you can say that domain of the function is 1 comma 5. Coming to the C part, the cos inverse x is a value which is lying between 0 to 1, and this angle y is equal to given as you know that cos inverse x is nothing but theta. It is a angle, so it is theta, and it is theta square up to infinity is 2. Okay, so for the part C, we notice that y is given as 1 plus theta and plus theta square up to infinity, and this value is given as 2. So you can say that where theta belongs to 0 to 1 given, we apply here, you can say that geometric series S infinity formula, which is A by 1 minus R. So where mod of R must be lesser than equal to R, lesser than equal to 1. So we have theta by 1 minus theta, uh, A value is 1. And this is given as 2. So what we can write, 1 minus theta is equal to 1 by 2. So theta is equal to 1 minus 1 by 2, that is half. But theta is what? Cos inverse of x, which is equal to half. So you can say that your x value should be cos of half. So this is the x value they are asking, which is nothing but cos of half. Question number D says that y value is sin inverse x6 plus 1 within the bracket cos inverse input is x to the power 4 plus 1 minus tan inverse of x square plus 1. Okay. Question number D they say that y is equal to sin inverse. Within bracket we have x power 6 plus 1. Then we have cos inverse x power 4 plus 1. Then minus tan inverse x square plus 1. So you know that tan inverse is defined for every real number. Whatever the x belongs to R, it is defined. But the problem will happen to these two, because they defined only the value is lying between minus 1 to plus 1. We have to take the intersection with this one and intersection with the largest one, real. So here you notice that x power 6 is less than equal to 0 and greater than equal to minus 2. Intersection x power 4 is less than equal to 0, greater equal to minus 2. Intersection with the set of real number. So now x having the even power is always non-negative. Okay, always non-negative. So what we know that x is any even power is always greater than equal to 0, like this one or this one. So what we can say that if we combine these two, or if we combine these two, we can say that x power 6 is 0, similar to x power 4. So from here we have x is equal to 0. So combining this solution, x equal to 0 intersection with the real number, so we have only x equal to 0 value. So since x equal to 0, the first value will become what? Our y is equal to sin inverse of 1, that is pi by 2, cos inverse of 1, that is 0, tan inverse of 1, that is pi by 4. So 90 degree minus 45 degree is again 45 degree, and tan of y is nothing but tan of 45 degree, which is 1. So this is the answer. I hope all of you enjoy this class, and later in the next slide we will do more interesting questions. So be in touch. Watch the next problem. All of you be with me. Okay, now going to next questions. Now in question number 2, we have 4 parts and we have to find the domain and range of all these 4 questions. So first question is y is given as cos inverse of box of x, and we have to find what is the domain and range of these functions. So all of you know that the necessary condition that cos inverse is defined is its input should be lesser than equal to 1 and greater equal to minus 1. So input should be between minus 1 to plus 1. So since there are the double inequality, we have to solve first this one. So box of x, a integer, is greater than equal to minus 1. From the this number line, try to understand if x is minus 1 to 0. If I take their box, it will be minus 1. If it is just less than minus 1, if it will be here, the box will be minus 2. But they are saying box of something will be greater equal to minus 1. So that means we can say that our x should be maximum can take minus 1 or less than will be here. So from here we can say that minus 1 less than equal to x. This is the first inequality. We solve this part. Now solve this part again. So box of x is 1 or less than 1. So if it is 1, then box of x is 1. If it is 1.1, box of x is 1. If it is 1.9, box of x is 1. If it is 2, box of x is 2. That means from here it is starting, just lesser than 2. So if x is less than 2, then its box is always 1 or less than 1. So if you do the intersection of this portion, x is greater than equal to minus 1. That means from here it is a start and going up to infinity. And x is 2 or lesser than equal to 2. Not equal to 2, no? Otherwise box become 2. So from lesser than 2 and it is going up to infinity. Can you notice? Can you notice what is the intersection region? This one. So our x lying between -1 to 2, open bracket. So this is the domain of the functions, cos inverse of box of x. Okay. Now we are interested in range. Box means what? Integer. So if I choose -1 to lesser than 2, and if I give any input, what will get here? So box of x will generate either -1 or 0 or 1. Nothing will be given by this box of x. It only generates the -1, 0 and 1. So its output is -1, 0 and 1, and this output cos inverse x will take as its input. So what will be the range of these functions here? So range will contains only these 3 points: cos inverse of -1, cos inverse of 0, and we will get cos inverse of 1. So if you look at the graph of cos inverse x, then what will we notice that when we give the minus input sign, the output will be pi. When we give 0, output will be 0. When we give 1 input, output is 0. So from here we will get what? Pi and pi by 2. At 0, it will be pi by 2, not 0. And at 1, it is 0. So this will be the range. I think it is clear to all of you. So this is the range of these functions. Range contains this one. Okay, now coming to sine inverse e power x. Sine inverse e power x. Find the domain and range. Okay, part B, y is equal to sine inverse e power x. Find its domain and range. Find its domain and range. Okay, no issue. So first of all, we know that the necessary conditions that sine inverse x is defined when the input is less than equal to 1, greater equal to -1. But we know that this function is what? Exponential functions. So if you look at the graph of exponential function, it will be look like this. It is always above the x-axis, that means it is positive, but the y-axis at the point 1, 0, 1 here, and we are interested the those values of x where e power x is lesser than 1. Okay, now. So what we have, e power x, we want lesser than equal to 1, greater than equal to -1, but it is always more than 0. So we have to find those x where it is less than 1 and going to just approaching to 0. Okay, now, so 0 to 1. So these x are possible. These x are possible because at the point 0 value is 1. So 0 is included. So from here we get x is lesser than equal to 0 and greater than -1. So this is the domain of the functions sine inverse x, sine inverse of e power x. So from here we can find domain. So domain will be -infinity to 0. This is the domain. Okay. So here we notice that e power x is positive and take maximum value 1. So when this value is positive and take maximum 1, to look at the sine inverse curve. What will happen to sine inverse curve when you give any input which is 0, not 0, positive and 1. So you notice that at the point 1, the height of the curve is pi by 2. You can reach at the point 1. So when you reach at the point 1, it will generate pi by 2. But you cannot reach at the point 0 because your domain, your value will be e power x. So this value is always greater than e power x is always greater than 0. So that means starting from here. Okay, now at the point 0, it is 0. So we want the output from 0 to 1. When we give input as 0 to 1 value, then output will be here. And for this value, we have this part as the output. So therefore, range of this function is 0 excluded and pi by 2 included. I hope this part is clear to everyone. Coming to the next question. Y is equal to sine inverse fractional part of x. Okay. So third questions. Y is equal to sine inverse fractional part of x. So necessary condition that our sine inverse functions will define. It is defined if the input will be less than equal to 1, greater equal to minus 1. But we know that our fractional part of x is always lesser than 1 and greater equal to 0. So this value, this range always satisfies this criteria. And this is true for every x belongs to real number because fractional part of x can take any real number and it will generate the output 0 to 1. And sine inverse has no objection to take 0 to 1 value. So therefore, we can say that domain of the function is must be equal to set of all real number. Is it clear? Is it clear? Okay. Now look at the graph of what sine inverse x graph. So all of you know that sine inverse x look like this one. So it is at pi by 2. It is at minus pi by 2. The curve is not actually sine inverse. The curve will be looked like this. Wait. Why it is minus pi by 2? It is 1 to minus 1. It is not. Next time, try. So it is at the point 1. It is at minus 1. Okay. So at the point 1, height is pi by 2. And here height is minus pi by 2. Clear? Okay. Now what we want at the point 0. So at the point 0, sin inverse x will generate 0. But at the point 1, it is pi by 2. You cannot take 1 because here is less than sign. So this will be this value you can't take. Otherwise, this part is the range. So therefore, you can say that range of the functions when you give input as the 0 to 1, 0 included, 1 excluded, will be 0 to pi by 2. So here pi by 2 in the open bracket. I hope this part is clear to everyone. Coming to part signum of x. So there is no objection of course to take any real value because domain is set of all real number. Again, signum of x is defined for all real number. So you can directly say that domain of the function is set of all real number. But the problem when you are going to calculate the range now, so whatever you give as an input, signum only generate the three values minus 1, 0, and 1. So what you have as the range, cot inverse of minus 1, cot inverse of 0, and you have cot inverse of plus 1. So when you look at the graph of cot inverse, what we notice that the cot inverse curve, it is x-axis, it is the line y is equal to pi, and it is your graph. it cuts at the point pi by 2. So now the value of cot inverse of minus 1. So minus 1 will be look like here. So for this value, you have some height here, and for this, you have some point on this one. So if I ask you, find the value of some angle theta, which will give you 1. The answer is cot, cot of theta is 1 at pi by 4. And minus 1, so it will be in the fourth quadrant or in the second quadrant, but your range will be lying to 0 to pi. So in the second quadrant, it will be pi minus pi by 4. So it is 3 pi by 4. Okay. So first value will be 3 pi by 4. Now next is cot inverse 0. So at the point 0, it will generate pi by 2. At the point 1, at the point 1, you will get some angle here. So find the angle theta so that cot theta will be 1. So you say that it is pi by 4. So this angle will be 45 degree. When we calculate the inverse functions, we are generally find the angle. So cot inverse ones means they are asking find the angle so that it will be 1 value. Find the angle so that cot of that angle, cot of theta will be 1. Now we are going to solve few more questions, interesting questions. Keep watching and just take and do the enjoyment. I hope all of you enjoy the class. Now we have the questions. This one here we have to find the domain and range of these functions. So coming to the question number 3 part A, y is equal to cot inverse log 4 by 5 and this quadratic expression 5x square minus 8x plus 4. So now there is no problem of the cot inverse x function to take any real number. So if this part is real, there is no problem. But log is defined only when if you give any positive inflow. So first of all, we have to check whether it is positive or not, or in which x, for which x it will be the positive. So first of all, you notice that discriminant will be negative, b square. You first calculate its discriminant. The discriminant will be d square minus 4 into 5 into 4, that is 64 minus 80, and it will be what? Minus 16, lesser than 0. Moreover, a is equal to 5, which is greater than 0. So in the class, I told you when any quadratic expression whose leading coefficient is positive and discriminant is negative, this quadratic is called beautiful quadratic because this quadratic always lies above the x-axis and it is the y is always positive. It is always lies above the x-axis. Okay now. So therefore this value is always positive. If it is always positive, now I want to, since it is quadratic, it's going on up to positive infinity. But what is its minimum value? So we have to check the minimum value of this quadratic. For this purpose, if I call this quadratic expression as p, so I want to calculate the minimum value of p. So p minimum will be minus discriminant divided by 4 times of coefficient of x square. So discriminant is minus 16 divided by 4 times of a is 5. So it will be 4 by 5. So its minimum value is 4 by 5. So now look at this log, its base is 4 by 5 also. So since 4 by 5, this number is lesser than 1. So this logarithmic function is the decreasing function. So decreasing, what will happen? It will be look like this. At the point 1, it is 0. But our value is 4 by 5 is the minimum value. So when it is 4 by 5, height will be here somewhere. This height we want to calculate. So when this minimum value 4 by 5 of the quadratic expression 4 by 5, then what we get? 4 by 5 minimum value, then 4 by 5 and base is 4 by 5, it is 1. Okay, it is 1. After that, what we notice that when you move, when you then the quantity will give what? More value, larger than 4 by 5. So if it is larger than 4 by 5, x will increase, then the curve will start decreasing and it's going on up to minus infinity. Okay, now clear? Up to this part is clear. So our input for cot inverse will be, that means this log is starting from 1 and this will give up to minus infinity. Okay, now therefore we have for the cot inverse, we have this input and this input ranging from 1 to infinity. So minus infinity, lesser than input, less than equal to 1. So what will be the output we have to calculate? Look at the cot inverse curve. It is your pi value. Now this is 0, pi by 2. Okay, now. So when x is minus infinity to 1, 1 is here. For the 1, we will get some value on the curve. This is pi by 4. And minus infinity, when x tends to minus infinity, that means your cot inverse tending to infinity. Since cot is the decreasing functions, so if you give the larger input, it will generate the minimum value. Okay, now. And if you give the lower value, minimum value, it will give the uh, uh, greater value. Okay, now. So lesser input, then greater output. So what we see that it will gives you at the point 1 pi by 4 and at the minus infinity it will give you pi. So it will be pi by 4 which is closed but pi is open. So this is the range of this function. I hope this problem is clear to everyone. So first of all, in this question you have to find whether the quadratic is positive or not. So if the quadratic is positive, then what is its minimum value? Because quadratic is what? It's going from minimum value to some infinity up to positive infinity. So since the log is what? The log is here decreasing functions. So if you go into the positive infinity x, the log will giving you the minus infinity. Now you have to again this input you have to give to the cot inverse functions. So again from the graph you have to analyze if you give this input to this what will be the output. So this is the logic behind that. Next is sine inverse log x by 3 base 3. Okay. Find the domain and range. Question number 2. Sine inverse log base 3 into x by 3. Okay. Coming to the B part. Y is equal to sine inverse log. Sine inverse log. And here 3. And this part is x by 3. Find its domain and range. So first of all, it is sine inverse. It is only defined input, when the input x by 3 base 3 will be less than equal to 1 and greater equal to minus 1. Since base is 3, so it will be what? 3 power minus 1 x by 3 less than equal to 3. Then 3 power minus 1 into 3, 3 power 0, 1 less than equal to x less than equal to 9. And log is defined when x by 3 is positive, that means x greater than 0. So 0 to infinity and where is 1 to 9. So if you take their intersection, the domain you will get 1 to 9. So domain of this function will be 1 to 9. Okay. Log base 3 is what type of function? It is the increasing functions. So what will happen? It is increasing functions. Okay. It is going from 1 to 3. Okay. So if you put here 1, what will you will get log 1 by 3 and 3. It is nothing but uh, log of 3 base 3, which is minus 1. So therefore, this will generate minus 1, and when you give here 3, it will be log 9 base 3 and 3. It will be a log of 3 base 3, which is nothing but 1. So what we notice that this value log of x base 3 and base 3 belongs to minus 1 to plus 1. Okay, so this will generate minus 1 to plus 1, and sine inverse is going to take minus 1 to plus 1. And this is the general domain of the sine. So in this range, sine gives output as minus pi by 2 to plus pi by 2. The range of this function is minus pi by 2 to pi by 2. This is the natural domain for what? Sine inverse. Sine inverse. Okay. So this is minus pi by 2 to plus pi by 2. I hope this problem is clear to everyone. Next is what? 3 cos inverse 4x minus 5. 3 cos inverse 4x minus 5. Root. Okay, going to next page. Problem number C. Root over 3 cos inverse 4x minus 5. So this under root functions, square root functions is defined only when it is uh, non-negative. So 3 cos inverse of x, 3, 3 cos inverse 4x minus pi is greater than equal to 0. So cos inverse of 4x is greater than equal to pi by 3. Okay, now look at the curve of cos inverse x. It is what? At the point minus 1. This is at the point 1. At the point 0, it is pi by 2. It is height pi. So now what we say that cos inverse 4 x, this theta is pi by 3, greater than equal to pi by 3. So now what we know that at the point half, it is pi by 3. Okay. So if I choose here half, and corresponding to this half, we have this 60-degree angle here, pi by 3. This is the 60-degree angle. Now cos inverse x is greater than equal to this 60-degree angle. So from 60 degree to pi, 60 degree to pi, this will happen. So 60 degree to pi, if we want to take, I have to find those x for which it will runs from pi by 3 to pi. So you notice that those x are this one, minus 1 to half. So therefore, from here we will get this 4x will be lesser than equal to half to minus 1. So therefore, x equal to 1 by 8 to 1 by 4. These are the values of x for which cos inverse 4x always greater than equal to 60 degree. And we know that this cos inverse x is the decreasing functions, and we know the domain. Okay, now, so since it is decreasing, we will just put the value of minus 1 by 4 and 1 by 8 in the given functions to find the range. Okay, now, so to find the range, we will put 2 cos inverse. When you give the minimum input, it will gives you the maximum output. 1 by 4, 1 by 4, and this 4. So it cancel out, it is minus 1, and minus 1 means pi. So it will be 3 pi minus pi, and it's a square root. So it will be 2 pi, which is nothing but root over of 2 pi. And when you give the maximum input, 3 cos inverse 4x, that is 4 by 8 minus pi. So it will be nothing but 3 1 by cos inverse 1 by 2. So cos inverse 1 by 2 means pi by 3. Pi by 3. So it is nothing but 0. So what we get, a range of this function 0 to root 2 pi. Okay. Now we will do more sums today. Some few questions are left. We try to cover here. Question number 4, part 1. Here we have to find the value of this expression. Now, you know that range of the sine inverse x function is minus pi by 2 to plus pi by 2. If I ask you find the angle for which is minus 1 by root 2, you simply say it is nothing but pi by 4. And for the cos, it will be in the 0 to pi. The range is 0 to pi. So you have to find the angle for which cos of theta will be minus 1 by root 2. So it is nothing but 3 pi by 4. Now for the tan inverse minus pi by 2 to plus pi by 2, open bracket. Now find the angle for which tan theta will be minus root 3. So it is nothing but 60 degree, minus 60 degree. And for the cot, it will be 60 degree, but since the cot lying between 0 to pi, range is 0 to pi, so it will be 2 pi by 3, 120 degree. So now 2 pi by 3. So now from here we get pi by 4. 3 pi by 4 minus pi by 4, it is pi by 2. And here we have 2 pi by 3 plus pi by 3, only pi. So it will be 3 pi by 2. When you have this type of question, how to find the value, you know that sine inverse is nothing but theta. So you can write here sine of 2 theta. It is a very, we know that the formula of this sine 2 theta, which is nothing but 2 sine theta cos theta. And what is your angle theta? You know what is theta? Theta is the sine inverse of 3 by 5. So that means you can say that sine of theta gives the value 3 by 5. So for this angle, sine theta, we will draw one right angle triangle whose perpendicular is 3, hypotenuse is 5, the base is 4. Now put here the 2 sine theta 3 by 5 and cos theta is 4 by 5. So 3 into 4, 12, 12 into 2, 24 by 25. I hope all of you clear this one. So here tan inverse 2 and tan inverse 3 exist, present. So what we say, this angle is alpha, this angle I am calling beta. So it will be cos of 2 alpha and it will be sine of 2 beta. So I know one value that alpha is the angle which is nothing but tan inverse of 2. So we can say that tan alpha is the value 2. Similarly, we have tan beta value which is 3. So I know the value of tan alpha, tan beta, and the angle is given here cos 2 alpha, cos 2 beta trigonometric ratio. So I will apply here the it is two angle formula, double angle formula. So 1 minus tan inverse alpha, tan square alpha, 1 plus tan square alpha. Here I am applying 2 tan beta divided by 1 plus tan square beta. Okay, tan square beta. So here 1 minus tan square alpha, tan alpha is 2 and its square is 4, 1 minus 2 square by 1 plus 2 square, and here 2 into 3 divided by 1 plus 3 square. 1 minus 2 square is 1 minus 4, that is minus 3 by 5, and here you have 6 by 10 which is again 3 by 5, which is 0. I hope all of you enjoy the class. Now do more sums. Now look at the question number 5. Here we notice that sine and cos given. This angle I am calling alpha. This angle I am calling beta. So solution of 5. I have sine of the standard result alpha minus beta. I can write sine alpha cos beta minus cos alpha sine beta. And what we know that alpha is nothing but sine inverse of 3 by 5. So from here we have sine alpha is equal to 3 by 5. Draw one triangle. It is 3, it is 5. So this value is 4. This angle is alpha. Now similarly do for the cos inverse. So cos inverse 3 by 5 is equal to beta. So we have cos beta is equal to 3 by 5. Now we have here, this is 3, this is 5, this is 4, and this one is the beta. So here we can write sine alpha value. Sine alpha we have what? Sine alpha 3 by 5, cos beta again 3 by 5, cos alpha 4 by 5, and sine beta 3 by 5, sine beta 4 by 5, sorry, sine beta 4 by 5. So it is 9 by 25 and 16 by 25. So 9 minus 16, that is minus 7 by 25. This is our answer. Next is tan inverse half of cos inverse root 5 by 3. Tan inverse half cos inverse root 5 by 3. Okay. Just copy these questions here. Solution of 6. Tan inverse half. Half means this part if I consider theta, it will be tan theta by 2, where my theta is cos inverse root over 5 by 3. Okay. We have to find the tan theta by 2 value. Okay. Now. So from here we have cos theta, which is root 5 by 3. So we should draw one right angle triangle. The base is root 5. Hypotenuse is 3. 3 square is 9. 9 minus 5, 4. 4 square root is 2. And we know that if I know the cos theta value and sine theta value should be 2 by 3. And with the help of sine theta cos theta, I can write this value is what? Tan inverse half of theta. I think this is not inverse. There is a mistake. It will be tan only. Tan half of cos inverse root 5 by 3 we have to find. Because there is one result 1 minus cos theta by sine theta. So this can be written as 2 sine square theta by 2. And sine theta formula is 2 sine theta by 2 and then cos theta by 2. After cancellation, you will have tan theta by 2. So tan theta by 2 we can generate with the help of 1 minus cos theta and sine theta. So what is our 1 minus cos theta value? Root 5 by 3. And what is sine theta value? 2 by 3. So after cancellation, we have 3 minus root 5 by 2. 3 minus root 5 by 2. This is the answer. Coming to these questions. Question number 7. We can solve here question number 7. Cot of some value. So this is nothing but theta. Cot theta is minus 1 by root 3, but cot inverse, the range is 0 to pi. So between 0 to pi, find one angle so that cot theta will be minus 1 by root 3. So it is nothing but the 120 degree. So here you will get cot inverse of minus 1 by root 3 is nothing but 2 pi by 3. And cos 2 pi by 3 is half. So you have sine tan inverse and cos 2 pi by 3 is minus half. We have this one. Okay. So sine tan inverse minus half we have to find out. So question number 7, sine tan inverse minus half we have to find. Sine tan inverse minus half. You know that tan inverse in the beginning I told you it is the odd function. So since it is the odd function, so what will happen for the odd function f of minus x should be same as minus of fx. So from here we can write minus tan inverse of 1 by 2. Now since again you know from the trigonometric standard result sine of minus theta is minus sine theta. So minus will be outside. So sine of tan inverse is half. Now this if I call theta, so it will be minus sine theta. We have to find only sine theta. So now tan inverse half I consider as theta. So from here I have tan theta which is equal to half. Draw one right angle triangle Half means it is perpendicular, it is base, so our hypotenuse is 5. So what we have 1 by root over 5. This is the answer. Now we have few questions left. We try to complete in this class. Here we want to find sine inverse of tan inverse 2 plus cos of tan inverse 2. This value I call theta. So I have to find the value of sine theta plus cos theta. Okay. So our theta is what? Tan inverse 2. From here we can find tan theta is nothing but 2. Draw one right triangle. Take this value is 2. This is 1. So it is nothing but root over of 5. So sine theta is equal to 2 by root 5. Cos theta is equal to 1 by root 5. That is nothing but 3 by root 5. Okay. Now coming to this part. This is I am calling theta. So I have the result tan of 2 theta minus pi by 4. This expression I have. And here I am going to apply the formula tan A minus tan B. So tan A minus tan B, tan pi by 4 1 divided by 1 plus tan A into tan B, so 1 by tan 2 theta. Uh, Now what we do, we know that this value is theta is nothing but 2 tan inverse of theta is equal to tan inverse of 1 by 5. So from here we have tan theta which is equal to 1 by 5. I have to calculate tan 2 theta whose value is 2 tan theta divided by 1 minus tan square theta. So which is 2 into 1 by 5 divided by 1 minus 1 by 25. So this can be written as 2 by 5 and then 25 by 24. So this will be 2, 12 and this is cancelling 5 by 12 I have. Okay. Now put this value here in these expressions, yellow expressions. So what we have 5 by 12 minus 1 divided by 1 plus 5 by 12. So 5 minus 12 that is minus 7 by 12 and 12 plus 5 that is 7 by 12. So we have minus 7 by 17. So I hope this part is clear to everyone. Okay. Coming to this one, cos inverse x plus cos 1 inverse y plus cos inverse z is equal to 3 pi and here separate variable used x, y and z and all these are nothing but the angle and the sum of the three angle is 3 pi and we know the range of every functions. It is 0 to pi. It is 0 to pi. It is 0 to pi. Okay, now this is equal to 3 pi. So this equality exists. The sum of the three angle will be 3 pi. The equality exists. Equality exists if and only if all the angles are pi. If you take the maximum value, then 3 pi comes. Cos inverse of x, cos inverse of y, cos inverse of z is pi. So from here we get x is equal to y is equal to z is equal to minus 1. Now put here what we get finally minus 1 power even. So 3 then 6 by odd power so minus 3. So 3 by minus 2 which is equal to this is our. I hope all of you enjoy this class here and in the next lecture in the second lecture we will cover the properties part and all of you connect with my channels and all of you please like and subscribe the channels and give your feedback whatever you have any doubts you can write in the comment sections. I will reply according to my convenience but I should reply. Okay na? And we will enjoy and we will learn a lot of things in the next class. Till then, bye. Have a nice day.